Welcome to Construction Math. Today's lesson is on solving systems of equations by the elimination or the addition method. In math, the substitution method is called the substitution method all the time. The graphing method is also called the graphing method all the time. But depending on your textbook, I've seen many different names for the elimination or addition method. So we're just going to take those two names, but by the time you see this, you'll understand what it means. All right, so for bell work, think about your definition of the term eliminate. Write your definition on your note taker, share with your partner, and teacher pause the video after the students have completed their math or their bell work, have them compare with their partners, call on non-volunteers, and I'll meet you back here in a minute. Welcome back. Possible answers for elimination means to completely remove or get rid of something and exclude from consideration. So that's basically what we're going to do today. So for math check, on your note taker, do these two problems which are simplifying math expressions, and I'll meet you back here in a minute. Welcome back. Let's go to our slate and let's look at these problems. The first problem said to take 3x plus 2x. Notice these are what we call like terms. They're like terms because they have the same variable to the same power. If they're like terms, then all we do is add their coefficients, the 3 plus the 2, and we get 5x. The second problem said 5x minus the quantity x plus 4. Remember, this negative out in front means to distribute inside the parentheses. So I'm going to distribute first, so I get 5x minus x minus 4. Now, remember, if a variable doesn't have a coefficient, it's always 1. So a positive 5x and a negative 1x gives me a positive 4x. And so I get 4x minus 4. So one of the skills that we're going to need to be able to do today is add like terms. All right, add this to your note taker if you missed a problem, and I'll meet you back here in a minute. Welcome back. Let's go back to our PowerPoint and look at our objectives for today. There we go. Our objectives for today are to define terminology, to explain the steps in solving a system of equations by the elimination or addition method, and to solve a real-world construction problem by the elimination method. So add the missing terms to your note taker. All right. Then we're going to go on. Our vocabulary for today, we have one term, and that's coefficient. A numerical or constant quantity placed before multiplying the variable in an algebraic expression. So for example, in 5x, 5 is the coefficient. In negative 2y, negative 2 is the coefficient. In a, the coefficient is 1, even though it's not shown. So what I need you to do is to draw a picture or a diagram, do a definition in your own words, and write a meaningful sentence. Teacher, pause the video, have students compare their meaningful sentence. Welcome back. Let's go on. Here's a problem. Foreman Al has twice as many roofing repair jobs as Foreman Bob. The cost of each repair for Al was $200 and the cost for Bob's was $100. The combined cost of all the repairs they did was $500,000, and we need to find out how many roofing repairs each foreman made. And so by the end of this lesson, you'll be able to solve this by the elimination or the addition method. So let's continue on. So the steps to solve this problem: we're going to identify the important information. We're going to define what the two variables are going to represent. In this case, Al's repairs and Bob's repairs. We're going to write two equations, and we're going to select a method to solve. In this case, the method we're going to solve is elimination. So we're on to our third or last way to solve these equations. So no matter what, remember, no matter which method you use, you'll always get the same answer. And remember to write each answer as an ordered pair, or if they work with a real-world problem, then all you need to do is label them. So in the elimination method or the addition method, here are the steps. Fill in the missing terms on your note taker. So step 1 is arrange each equation to have the same format. That means the x's are in the same place, the y's are in the same place, the equal signs in the same place, and the constant terms in the same place. Step 2, add a multiple of one or both of the equations together so that one of the variables, the x, the y, have the same coefficient but are opposite in sign. Because in number 3, we want to be able to add the equations together to eliminate one of the variables. So if we have a 4x in one of the equations, we need a negative 4x if we want to eliminate the x's. Solve for the variable and then substitute that value into one of the equations and solve. So fill in the missing terms, and in just a minute, these 5 steps are going to seem a lot more understandable. So pause the video, teachers, if students need that chance to finish copying down the terms. Welcome back. Here's an example without doing any math whatsoever, any algebra. What I want you to do is figure out 2 numbers that add to be 8. But when you subtract the 2 numbers, the answer is 4. Can you find the 2 numbers? Pause the video and have students share with their partner and call on non-volunteers. Welcome back. Here are the numbers. I found 6 and 2. 6 plus 2 is 8. And when I subtracted 2 from 6, I got 4. So we're going to use this example to solve by elimination. So we're going to solve this system of equations. So let's go to our slate. And let me copy down the 2 equations. X plus y is equal to 8. And x minus y equals to 4. Now notice, here's what I'm thinking. First of all, are they in the same format? Yeah, the x's are all together, the y's are together, the equals are in the same place, and the constants. It really doesn't matter what it looks like as long as they match. I look at this and I ask myself, if I add these 2 equations together, will one of the variables be eliminated? And I look at this and I go, oh, I have a positive y and a negative y. They're inverses, so if I add them together, they'll cancel out. So let's go ahead and do that. So I'm going to draw a line. X plus x equals 2x. The positive y and the negative y cancel each other out. 8 plus 4 is 12. The inverse of multiplying by 2 is dividing by 2. So I found out x is equal to 6. So in my order, remember my answers are going to be in an ordered pair. The 6 comes where the x is. So now I'm going to substitute it in. I can substitute it into either equation. In fact, I'll do both just to show you. If I put in the first equation the 6 where the x is, and then I'm going to solve it for y. The inverse of a positive 6 is a negative 6. So I get y equals to 2. So there's one answer. And that matches what we found. I could also have plugged it in the second one. So I could have 6 minus y equals 4. The opposite or inverse of a positive 6 is a negative 6. So I get negative y equals negative 2. Divide both sides by negative 1. So y is equal to positive 2. No matter which one I did, I got the same answer. You only have to do one of them. So add this example to your notes, and I'll meet you back here in a minute. Welcome back. Let's clean off our slates, and let's go back to our PowerPoint. And let's see. We found out that we let x equal the first number, y equal the second. Did the variables have the same coefficient but opposite sign? Yes, they did. So here I worked it out, and it's just a nice, neater way of showing it to you. All right, so here's an example where they're in different formats. So I'm going to go to my slate, and I'm going to go ahead and work this out and explain it to you before we just look at this. All right, so here we go. We have x plus y equals 1. We have 2x equals y minus 10. Now I remember on my PowerPoint, the next slide is going to ask you to solve. We have to make a decision. We can solve for x or we can solve for y. So I'm going to make that decision, and we're going to solve this one for x. And I'll show you in just a minute that it doesn't matter, but we're going to solve this guy for x. So what we're going to do is we need to get both of these equations in the same format. I like the format of the first one, so I'm going to have to change the second one because notice the equal sign is in a different place. It has the x on one side of the equal sign, the y on the other. I want them both on the left-hand side. So the first thing I'm going to do is subtract y from both sides. So I get 2x minus y equals negative 10. Now I can use these two, and notice they are the y's. We're going to solve for x, so the y's are inverses. They're going to cancel out. So would you take a second and just add those two equations together for me? All right, when we add x, remember that's 1x, even though it's not shown. So 1x plus 2x is 3x. A positive y and a negative y cancel out. A positive 1 and a negative 10 give me a negative 9. So I'm going to divide both sides by positive 3, so I get x equals negative 3. So in my order pairs, remember the x's come before the y's. I can substitute it into this equation right here, this equation, or this equation. I think the first one just looks the simplest. So x is 3 plus y equals 1. The inverse of a positive 3 is a negative 3. So I'm going to get y equals negative 2. And there's my answers. So let's go ahead and clear that off. If you need to pause it, please do. Let's go back to the PowerPoint and skip through that. And here we go. Here's a you try. What I want you to do is get the x in the second equation over to the other side and then add them together and solve the equation. All right, once you get a value, this time for x, substitute it in and find out what y is. So teacher, pause the video, have students work with their partners to do this one, call on non-volunteers, and I'll meet you back here in a minute. Welcome back. Let's go to our slates and let's work this problem. So I have 3x plus 4y is equal to negative 5. I have negative 4y is equal to x plus 7. So I'm going to keep the first one the same because it looks like a nice tidy format. So I'm going to move the x to the other side. I'm going to subtract x from both sides. So I get negative x minus 4y equals 7. So I get negative x minus 4y equals 7. Notice that the y's again are inverses, so they're going to cancel out. And remember, this is a 1 here. So 3x and a negative 1x give me 2x. Negative 5 plus 7 is 2. Divide both sides by 2. So I get x equals 1. So in my answer, remember again, x's and y's. I can substitute it into any equation. I think I'll substitute in the bottom one, just to be different this time. 4 times y equals 7. So I'm going to add 1 to both sides. I get negative 4y equals 8. Divide by negative 4. So y equals negative 2. And there are my answers. You could have solved it in put it in the top one, whichever equation, it's your choice. So the addition method really has addition first, and then we still do substitution. So teacher, pause the video if students need a chance, and then we'll meet you back here in a minute. Welcome back. Let's go back, let's clear this off and go back to our slide. And here's our second one. What happens if the coefficients are not opposites? So far, every problem that we've done, the coefficients turned out to be opposites. But this time it says, let's decide which variable to eliminate. Normally it's your choice, but so that we all do the same thing, we're going to try to get rid of the y's. We need to make sure the y's have the same coefficient but opposite in sign. So let's go to our slate and we're going to copy down the problem. So 7x plus 4y equals 25. 3x minus 2y equals to 7. So there's two things I need to do. I need to make sure they're opposite in sign. Well, they are opposite in sign. Now what I need to make sure they are is the same coefficient. This is a 4 and this is a 2. Well, if I double the 2, it would become 4. So that's what I'm going to think I'm going to do. I'm going to multiply the whole second row by 2. I'm going to keep the first equation the same and multiply the whole second equation by 2. So 2 times 3x is 6x. 2 times negative 2y is negative 4y, and 2 times 7 is 14. In this case, you can multiply either equation or you can multiply both if you wanted to. For example, if I wanted to get rid of the x's, I'd multiply the top row by 3 and the bottom row by 2, making one of them negative. I think I'd multiply the bottom row, oh, I'm sorry, not by 2, by -7. So they both come out to be 21. Your choice. There's multiple ways of doing each problem. So let's go back to what we started with. 7x and 6x is 13x. These are inverses, they cancel, and 25 plus 14 is 39. Divide both sides by 13, so I get x equals 3. So I can plug it in, remember our answers are ordered pairs, and I can substitute it into the top one or the bottom one. Let's substitute it into the top one. And let's see what we get. 7 times 3 is 21. Subtract 21 from both sides so that I can get the y's all by himself. So I get 4y equals 4. Divide both sides by 4, so y is equal to 1. And that's my answer. So take a second, pause the video. When we come back, I'm going to clear off the slates and then I'm going to get rid of the x's so that they cancel. Welcome back. Let's work this same problem. And let's get rid of the x's instead of the y's and see if we truly do come up with the same answer. We have 3x minus 2y equals 7. All right, I'm going to multiply the top row by 3 and the bottom row by 7, because all I do is bring this guy down here, this guy down here. And I'm going to make one of them negative. I'll just make the bottom one negative. So 3 times 7x is 21x. 3 times 4y is 12y. 3 times 25 is 75. Negative 7 times 3 is x is negative 21x. Negative 7 times negative 2 gives me positive 14y. And negative 7 times 7 gives me negative 49. So I get these cancel because they're inverses or opposites. So I get 26y equals, let me see here, 6. Oh, that should have been a 6. Oh, it equals to 26. Divide both sides by 26. So y is equal to 1. That means when you write your ordered pairs, y is 1. Let's put it in the bottom one just to do something different. I know y is 1, and that should have been a 2. So I get 3x minus 2 equals 7. Did I do that correctly? 3x minus 2 equals 7. Oh, yes, I did. Add 2 to both sides. 3x equals 9. Divide both sides by 3. So x is 3. I got the exact same answer, but did the work in a completely different way. And that's one of the nice things about these kind of problems, is that there's many ways to do them. So pause the video until you've had a chance to look this over, and I'll meet you back here in a minute. Welcome back. Let's go back to our PowerPoint, and let's see. We took the problems, we multiplied the second equation by 2, and we got x equals 3, substituted and got 1. You try this problem, and you eliminate the x's, your choice. So teacher, pause the video and give the students a chance to work this problem. Welcome back. Let's go to our slate, and let's look at this problem. We have 3x plus 2y is equal to 7. We have 4x minus 3y is equal to negative 2. All right, I want to eliminate the x's because that was my choice. So I'm going to multiply the top row by 4 and the bottom row by negative 3. That gives me both coefficients of 12. One will be positive, one will be negative. So 4 times 3x is 12x. 4 times 2y is 8y. 4 times 7 is 28. In doing this, after all these years of teaching math, I know that the biggest mistake is people forget to multiply the other side by 4. So negative 3 times 4x gives me negative 12x. Negative 3 times negative 3y gives me positive 9y. Negative 3 times negative 2 gives me positive 6. So let's go ahead and add these up. I get 17y equals 34. Divide both sides by 17, so y is equal to 2. So in my answer, y is equal to 2. Let's put it back in the top one. 2 times 2 equals 7. 3x plus 4 equals 7. Subtract 4 from both sides, so I get the x by itself. 3x equals 3. Divide both sides by 3, so x is equal to 1. And that was my answer. All right. Teacher, give the students a chance to make sure they got all those notes, and I'll meet you back here in a minute. Welcome back. Let's go back to our PowerPoint. Here's my answer. I got the same one. So here we're going to do the problem that we started out with. I said I was going to teach you how to solve this problem. So you underline the important information. Teacher, pause the video and have students compare with their partners. Welcome back. So I just put mine in color. So Al has twice as many as Bob. The cost of Al's was $200. The cost for Bob's was $100. Combined, they had $500,000. So I remember from another lesson that the term combined means to add them together. So what I need to do now is how many of each roofing repairs did each foreman make? So I'm going to set these equations up. I'm going to let x equal Al's repairs, y equal Bob's. You certainly can use a and b. So x equals 2y because Al's had twice as many as Bob. Al's were $200, so 200x, plus Bob's was 100, so that's 100y equals 500,000. So these numbers are pretty large. That's probably one of the reasons for this problem I never would do graphing, is because I don't want to have to make a chart that goes all the way up so far. So let's go ahead and you copy this problem down, and then let's go to our slate. Okay, so we have two equations. We have x equals 2y. We also have 200x plus 100y equals to 500,000. Now I know this is a real world problem, so I know that we're talking about number of repair jobs. I know my answer cannot come out to be negative. So the first thing I have to do is make this in the same format. So I'm going to take this first equation and move the 2y over. So I get x minus 2y, and remember 2y and negative 2y equals to 0. So there's my first equation now, equals to 0. Copy the second one down. And I have to decide whether I want to eliminate the x's or the y's. So let's eliminate the y's. So you stop for a minute and you solve this problem, and we'll meet you back here in just a few minutes. Welcome back. We're going to eliminate the y's. So they're already opposite inside. This guy's negative, this guy's positive. But I want them to be the same value. Think about what I have to multiply 2 by to make it 100. I'm going to multiply it by 50. So I get 50 times x is 50x. 50 times negative 2y is negative 100y. And 50 times 0 is 0. Copy down the next equation because I don't need to change it at all. So add them together. 50 and 200 give me 250x. A negative 100y and a positive 100y cancel out. Oh, it looks like it's going to come out to be a pretty answer. Divide both sides by 250. And I get the answer of x equals 2,000. I'm sorry, yeah, x equals 2,000, and that's Al. Substitute it back in. I think I'm going to put it back into this top one because it's the simplest. So 2,000 equals 2 times y, divide by 2, and so I get 1,000 equals to y, and that's Bob's repairs. All right. Even if you did it a little bit differently, you should still come out with the same answer. Teacher, pause the video until students have had a chance to add this to their notes if they need to or look it over. Welcome back. Let's go back to our PowerPoint. And so we've got it worked out, 2,000 and 1,000. So think, pair, share. How do you know which method to choose? Which is the best method for graphing, substitution, and addition or elimination? Discuss with your partners Teacher, call on non-volunteers and I'll meet you back here in a minute. Welcome back. How do you select the method? You do substitution when it's easy to get a coefficient of 1 for either variable. So if there's a coefficient of 1 or something easy to do, that's the best. It's easiest to use elimination where we can get them opposite, or when substitution would overcomplicate where you get a lot of variables. And the last method you choose would be graphing. And that's where you're pretty sure that the answers are going to be integers, not fractions. So in order, I would do either substitution elimination first and graphing as my last choice, unless the problem said to graph. Because if numbers get very large, very small, or are fractional, it's going to be very hard to get an accurate answer with graphing. And so now, your closure, tweet a friend using 140 characters or less what you learned about the elimination method today. I'll meet you back here in another time for another construction math.